Hi everyone, today we are going to solve the derivation of x power n, and in x power n we have n which is belong to z, and you know that z is integers and we are going to solve the derivation of x power n, and n approaches to integer. For that we are going to use binomial theorem and binomial theorem is like if we have a plus b power n, then we will do something like this one: a power n plus n1 and a n minus 1 b plus n2 and a n minus 2 b2, and it will goes, and we finally get b power n. As you can see that we have n, first n has the power n, and here b power is nearly 0, and something power 0 is equal to 1, and here we get b power 1, and a will just decrease to power will decrease one time, and we have also n and 1 and here it will goes to 1 2 3 4 5, and it will continue to n, and we have b since it is not, and 1 2, and it will go to n, and since a is increasing, then it will go here like a power n minus n, which will be is equal to 0, and a0 is equal to 1. Now therefore if we have y, for example, and let me just show you, if we have y which is x power n, then we will do like y plus del y. If we are going to make some changes here, then x plus del x, which is n. Now since we are finding the derivative, therefore we are going to take y to right hand side, and we will get like x del x power n minus y. Then we will do like del y is equal to x plus del x power n, and here we have the value of y. We will bring that to here, and it is x power n. Now further we are just going to attempt a binomial theorem like this one which we had here, and therefore we just do one thing, del y which is equal to x and n1, which we have x, and we will get like n minus 1. Here we will get xn, and we have del x and plus n2, which we are going to do something xn minus 2 and del x power 2, and plus it will go so on and so far to del x power n, and since we have one more minus x, we are going to write x power n, and you can see that we have here x power n, and that too will cut down with each other, and we will get like del y is equal to n, and I will just expand that one, n xn minus 1 del x plus n minus 2 factorial, and it will be xn minus 2 del x square plus del x power n. Now further we are just going to attempt like del y which is equal to we are going to take common del x from all of these series, and it will be like this one del x. We will get n xn minus 1. I have just took common del x, and it will in here will be 1, and n minus 2 and 2 factorial we have, and xn minus 2, I have took 1 del x from here, then it will look like this one, and we will get del x and n minus 1. Okay, further we are going to attempt that one, and we are going to say that dividing both inside with del x, and when we are going to divide with del x, then it will look like dy over del x and del x over del x, and we have n x n minus 1 and plus n minus 2 factorial, and further we have x n minus 2 del x plus sorry, when we are going to take common del x, yeah, that is fine, del x and n minus 1. Further it will cut down with each other, and we are going to take the limit here, both inside, limit del x approaches to 0 and del y over del x, which is equal to limit applying on all of them. Then here we are going to limit del x approaches to 0 and x n minus 1, and further we have limit del x approaches to 0 n minus 2 over 2 factorial x n minus 2 and del x, and it will continue like limit del x approaches to 0 and del x n minus 1. Okay, further we have like what we are going to do, that applying del x to all of them, here it will go to 0 and that will also go to 0, and we will get like we have dy over dx, which is equal to n x n minus 1, and therefore we have got that when we are just going to like, if I'm going to put the value of y from here to this one, then we will get d over dx x power n is equal to n x n minus 1, and that's how we are going to derive or derivate the n power to any variable, and it will be like x n x, and it seems that we have just took that n to the front and just in minus 1 time to that power, and that is how we are going to derivate any function or any function when it has variable and it has a power. I hope you got the idea, and that's it. We will meet with the next question, and for now, goodbye.